Dear Sumit sir, my name is Nitin Avasthi and my roll number is G24AI1009. Sir, cloud computing is a new subject for me to understand and I have made every effort to complete all the requirements of the assignment. These are the topics I have covered in the upcoming slides. As per the given objective, I have divided the assignment into three parts as asked. First, I explained how I created the VirtualBox and set up three multiple VMs. In the second part, I detailed how I connected these three VMs internally using dedicated IP pool from my host computer, as well as how I connected them to the internet to download and the required software on the VMs. Finally, I deployed a Flask-based microservice on all three VMs, which I will explain further in the next section. So this slide describes the installation process of a VirtualBox step by step. Means how I downloaded VirtualBox first time on my computer and how I installed the VMs. So all the steps involved in the installation of VirtualBox. In general, this slide will give you insight how to download and install VirtualBox on the system with the basic setup instructions. Now, this slide explains how to download the Ubuntu ISO file, which is necessary for installing Ubuntu on a virtual machine inside VirtualBox. I downloaded the .iso file for the VM because it serves as a virtual disk image of an operating system, allowing us to install and boot the OS inside the virtual machine. And this is the final outcome of the VirtualBox installed on my computer, where I will where I will create multiple VMs, which I will show you in the next slide. So these are the various steps involved, like configuring the RAM and memory for a VM. Likewise, we need to select the folder .iso file which we downloaded earlier, and what is the minimum RAM size we are considering here. Here I'm considering 4 GB because in the Ubuntu 24 version, minimum RAM requirement is 4 GB. Default CPU configuration I have selected. Then I have taken 25 GB space for the Ubuntu installation. Now we can finish the installation, and the final outcome will look like this, where the one virtual machine is installed. Now, similarly, we will install other VMs as well. So you can see in the window, I have created three VMs, V1, V2, V2 with the same configuration of RAM, 4 GB RAM and 24 GB space. So once I will click on the start in the virtual box platform, the following window will appear. Means the Ubuntu OS will start booting up and finally it will install on our computer. And I will edit same steps for for all other two VMs as well for the installation purpose. Now the next part of my assignment is the internal connectivity of the VMs through IPv4. So for the internal connectivity of the VMs, I first created an IP pool in the DHCP mode, which automatically assigns IPs to my VMs. The network address I considered is 10.0.2.0 and the subnet mask is /24, which allows me to use 254 usable IPs. And I set up three IPs for my VM: 10.0.2.4, 10.0.2.5, and 10.0.2.15. And I have assigned this, I have explained this in my subsequent slides. These are these are the steps which I have followed to install on my host machine. These are few commands. Then few changes I need to do in the VirtualBox settings as well, where we need to create two adapters. One is for the internal connectivity of our VMs and second is for the connectivity with the internet. So here, this is the place where I did the changes, and you will see the assigned IPs. Means for the internet, I created two adapters. So in the wired section, you will see two options: Ethernet ESP0, S3, and ESP0. When we click down this, you can see the IPv4 assigned is 10.0.2.5 is my VM2, and the IPv6 adapter 2 is connected with the IPv6. This 10.0.2.5 will be used for the internal connectivity of my VMs, and it is a dynamic. It's a static. It's a dynamically assigned static IP for my VMs, and my VM is also connected to the internet as well. And for the internet, and three VMs are internally connected also. So this is the ping results. So this is the ping results on my VMs, the VM1, self, VM2, and VM3. From VM self, I pinged VM2 and VM3, and these are the results. Similarly, I pinged VM2 self and VM3. And from VM3, I pinged self VM3 with 2.5 and VM2. I will give you a demonstration here. Demonstration. Suppose I have a VM1. I will go to the terminal part. If I will ping 10.0.2.4, which is my VM1 IP, my IP is pinging. Similarly, if I will ping 10.0.2.5, which is my VM2, it is also pinging from here. And if I will ping 10.0.2.15, this is also pinging. So like this, my all three VMs are connected to each other. So this is what I have explained in these slides. Now, since my internal connectivity is done and my network is connected to the internet as well, and I connected internet because there are a lot of files which we need to download during our microservices deployments. So now the Flask now my Flask-based microservice deployment across three VMs is my microservice APIs, which I have installed on my three VMs. Uh, and I have chosen this specific microservice because after installing three VMs on my laptop becomes extremely slow and started hanging continuously. Due to this, I decided to install a small RESTful API-based microservice that fulfills the objective of my assignment while also enabling me to understand the topic effectively. So for the three VMs, VM1, VM2, and VM3, there's these three IPs I have assigned 10.0.24, 10.0.25, and 10.0.2.15. And for each VM, the VM1 will act as an API gateway, VM2 will act as a worker node 1, and VM3 will act as a worker node 2. So this is the architecture diagram. This diagram explains the microservice deployed on three VMs. A client sends a request to the VM1, which is an API gateway, and VM1 handles the request and provide a status API to check its availability. VM1 distributes the request to two worker nodes. The VM2 is a worker node 1 which handles contribution of VM2, and VM3 worker node 2 which handles the contribution of VM3. And each worker node processes its assigned task response accordingly. In simple words, this setup divides the workload across the multiple VMs where VM1 will act as a gateway and VM2 and VM3 will act as a worker to handle the specific tasks. And now this describes how V1, which is an API gateway, will act as a central communication point in the microservices architecture. Here, user sends a request to the VM1, which is 10.0.2.4 on the port 5000. The API gateway fetches the data from VM2 and VM3. The VM2 will handle the data processing service, and VM3 will handle the log maintenance service. Uh, the the API gateway combines the response from both the services and send a unified response back to the client. In simple words, VM1, the API gateway, will act like a middleman between the client and the worker nodes. It gathers the data, it will process it, and it will return the structured response. Even if one worker fails, it still provides partial results to avoid any failure. Here I have shown the output of the response of the gateway API. Similarly, Similarly, this slides describe the role of worker node 1, which is my VM2, in the microservice architecture. It will act as a data processor, which is responsible for data analysis, such as processing sensor data, performing real-time calculations, and allow external systems like API to fetch this status. This response confirms that the VM2 is actively processing the sensor data. Here the example response. I mean, the response confirms the VM2 is actively processing the sensor data. And how this fits into the architecture, VM2 will process the data and it returns a JSON response. The API gateway VM1 collects the response and aggregates it with the data from other worker nodes, and the final output is then sent back to the client. Similarly, worker node 2, which is a VM3, will act as a log manager in this microservice architecture, and it is responsible for handling the logs, debugging, and monitoring activities. This node exposes an API endpoint contribution, allowing the API gateway to check its status. When the request is uh, sent to HTTP 10.0 to 15.0 contribution, it responds with a JSON message confirming that it is actively managing the system logs, like worker node 1. And its response is collected by the API gateway VM1 and aggregated with the other worker node response and returned to the client. This setup ensures that the logging service are running efficiently within the system. So, how they work together means how these three VMs will work together. The VM1, which is an API gateway, will act as a central communication hub. It receives the request from the client, forward them to the worker nodes, and collect their responses and returns a combined result. VM2 will act as a worker node and is responsible for data processing. It performs tasks like center data analysis, real-time calculations, and when the API gateway requests its contribution, it responds to the relevant data. Similarly, VM3, the worker node 2, handles log management and it processes system logs, debugging, and monitoring tasks. The API gateway collects this information to include the final response. And how they finally communicate, the client sends a request to the VM1 on port 5000, VM1 forward the request to the VM2 port 5000 and port 5002, and both worker nodes return their respective contributions. VM1 aggregates these response and sends a final unified response to the client. So this is the physical code I use to install on my VMs, like Flask on each VM and VM codes for work node 1, whose reference is available in the GitHub repository. I run all the microservices APIs on each VM and test it by curl command. Similarly for VM, another VM also. This is the testing results of the VM3 and it will tell the task assigned to him. So the API gateway is deployed on VM1 using Flask to act as an aggregator that collects the response from the worker nodes. And it defines the endpoint which sends requests to the VM2 for data processing and VM3 for log management. And it works, if a worker node responds successfully, its data is added to the final response. And the API gateway ensures fault tolerance, meaning even if one worker fails, it still returns partial results. This setup allows efficient communication between VMs and ensures scalability and reliability in the microservice architecture. So the final slide. This project, after doing all this, I can conclude that this project successfully demonstrates the deployment of microservice architecture across three VMs using Flask-based APIs. VM1 will act as an API gateway aggregating response from two worker nodes, VM2 and VM3, and the system is designed for the efficient communication, fault tolerance, and scalability, ensuring that the response are collected and processed even one node is fails. Thank you. And I will show you how I deployed in my system all these things. So let me open VM1 first. Similarly, I will open VM2 also, and VM3 also. I'm getting some issue in VM3. Let me reopen VM3 from here. VM3. Meanwhile, I will go to the VM1 and I will run main gateway API here. So my main gateway API is rename dot pi. So you can see this API will start running on this. This is the main API gateway. Similarly, I will go to the VM2 for a worker node. So I will go to the worker node here. I will go to the terminal and I will run another API here. So which is Python 3 and my API is present in my downloaded folder. Work rename. So this will also starts working. Similarly, I will go to the third VM for worker node 3. Okay, so this is also working. I will go to the terminal and I will learn the third microservice here. So my all three services are running. So let me check the output. So if I will go to the step-by-step implementation, so this response will tell me the status of my all work nodes. Cool. 10.0.2 or 2.4, then port number, then status. So you can see it will show you the main VM is VMware and the worker contribution of data processing VM2 and contribution log management VM3. So it is showing the output as I have shown in the my slides as well. So similarly, if I will go to the VM2 a worker node and I run curl http 10.0.2.5 slash, sorry, 50001 contribution. Sorry, curl is not in this one. Let me add sudo snap install curl. Meanwhile, I will go to the VM3 and I will do same setup for the VM3 as well. So for the VM3 node, I will use curl http 10.0.2.15. मेरा port number is 5002 slash contribution. So it will show the contribution is like log management and VM3. So this is the final. If I will run this, a request from the start status will return the contribution from both the workers, error correcting and manage. So if I will run this on VM1, you will see the contribution of my all three VMs. So with this, I can conclude that my all three VMs, I have created three VMs on my system. This is one, two, and three on my host machine. Then I interconnected them with each other that I shown the ping from one VM to another two VMs, and I've run this microservices. I've run this microservices which based on API gateway and worker node, and output of these APIs are also working here. So with this, I conclude my assignment. Thank you, sir. Thank you so much.